Determine the equation of the tangents to the circle which are parallel and perpendicular to the line 3x minus 4y minus 1 equals to 0. Let us begin. So here we will start with a circle. So here we have two tangents, tangent T1 and tangent T2. T1 is tangent to the circle, let's say at point A, and T2 is tangent to the circle at point B. We have to determine the equation of tangent T1 and tangent T2 with the condition given here. The tangent T1 is parallel to the line, let's say 3x minus 4y minus 1 equals to 0, and tangent T2 is perpendicular to that same line. Let us begin. First, what we'll do, we'll try to find out the coordinates of the center C of the circle from the given equation of the circle. For we have given here x squared plus y squared minus 2x minus 4y minus 4 equals to 0. So what we'll do, we'll compare this equation with the general equation of a circle, which is given by x squared plus y squared plus 2gx plus 2 times fy plus c equals to 0. Now immediately it follows that the value of 2g will be equals to negative 2. 2f is going to be equals to negative 4, and the c value, that's going to be negative 4 as well. So g comes out to be negative 1, f comes out to be negative 2, and c is negative 4. Now the coordinates of the center of the circle is given by negative g comma negative f, which means that our center of the circle is going to be 1 comma 2. And we can also find out the radius of the circle. So the radius will be the square root of g squared plus f squared minus c, which means g squared will be 1, f squared will be 4, c is negative 4, we have negative of negative 4, so that's going to sum up to 9, which is 3. That means the radius of this particular circle is going to be 3. Now let's try to find out the equation of the tangent line T1. To do that, we will need to have the slope of the straight line whose equation we are given. So here we have, let's say we have the equation 3x minus 4y minus 1 equals to 0. Now if we isolate y, so y will be equals to 3 over 4 times x minus 1 over 4. Meaning, if we compare it with the slope-intercept form of a line, which is given by y equals to m times x plus c, then the coefficient of x, which is 3 over 4, is going to be the slope. So slope m is going to be equals to 3 over 4. Now, since we want to find out the equation of tangent T1, what we'll do, we'll try to define the slope of tangent T1. So let the slope of T1, the tangent line T1, be equals to m1. But we know that the slope of m1 will be exactly equals to the slope of the straight line. That means they are going to have the same value, 3 over 4, because parallel lines have equal slopes. Now that we have this value of the slope, we also know the radius of the circle, which is 3 units. We are ready to find out the equation of the tangent. So let the equation of the tangent, we're going to suppose that the equation of the tangent T1 be 3x minus 4y plus lambda equals to 0. So its equation is going to be similar to that of the equation of the straight line, except for the value of the constant. So here we will be considering lambda instead of negative 1. Now our goal will be to find out the value of lambda. All we have to do is join point C and point A. We have already obtained the coordinates of point C, so that's 1 comma 2. Now what is the distance CA? CA is nothing but the distance of the point C, 1 comma 2, from the straight line, which is the equation 3x minus 4y plus lambda. That's the equation of the tangent line T1. So we can use CA equals to the absolute value of, all we have to do is take the ratio. First we will begin with the coefficient of x, so that's 3. 3 will get multiplied to the x coordinate of the center, so that's 1. Then we will consider the y coefficient of y, which is negative 4. This will get multiplied to the y coordinate of point C, so that's 2. added to lambda divided by the square root of, so here we will take the square of the coefficient of x, that's 3 squared, added to the square of coefficient of y, so that's negative 4 squared. Fine. The radius of the circle came out to be 3, which means that the length CA is 3 units. That will be equals to, now we have 3 minus 8, so that will be negative 5, so we have lambda minus 5 divided by square root of 3 squared plus negative 4 squared is simply 5. So we get absolute value of lambda minus 5 equals to 15. This is going to give us lambda minus 5 equals to positive 15, or the other possibility will be lambda minus 5 equals to negative 15, which implies that lambda will be equals to 20 or lambda will be equals to negative 10. So we have the equation of the tangent. Therefore, the equation of the tangent T1 will be, we have two such tangents. One of the tangent is going to be having the equation 3x minus 4y plus 20 equals to 0, and the other equation will be 3x minus 4y minus 10 equals to 0. That's because we can consider one more tangent which is going to be parallel to tangent T1. So let's call it T1 prime. And this is also parallel to the line 3x minus 4y minus 1 equals to 0. That's why we're getting two equations of the tangent line. Now we'll go to the next tangent T2. Now we want to determine the equation of the tangent line T2. Let us begin. So let this slope of the tangent line T2 be denoted by M2. We note for a fact that the two lines which are perpendicular to each other, then the product of the slope of M with slope M2 will be negative 1, which implies that M2 must be equals to negative 1 over M. We have M is 3 over 4, so M2 will correspond to negative 4 over 3. So that's going to be the slope of the tangent line T2. Now, what we'll do, we'll suppose that let the equation of the tangent line T2 be given by the slope intercept form y equals to m2x plus, we're going to consider alpha here. So we don't know the y-intercept, so we're supposing it's alpha. So y will be equals to negative 4 over 3x plus alpha, which gives us 3y equals to negative 4x plus 3 alpha, or we can say 4x plus 3y minus 3 alpha equals to 0. So our goal will be to determine the value of alpha here. Now, how shall we determine the value of alpha? So we'll again use the same concept. We'll try to find out the distance CB, which is the distance of the point C from the tangent line T2. So CB will be equals to, we'll take the absolute value. So first we'll consider the numerator, where we'll start with the coefficient of x, that's 4. 4 will get multiplied to the x coordinate of the center, that's 1. Then this will be added to the coefficient of y, which is 3, multiplied to the y coordinate of the center, so that's 2. And then we have the constant term, so that's negative 3 alpha divided by the square root of coefficient of x squared plus coefficient of y squared, so that's 3 squared. Now CB is also the radius of the circle with 3 units, which means that now we get the equation 3 equals to absolute value, so 4 plus 6 will be 10, 10 minus 3 alpha divided by square root of 25, which is simply 5. Now let's solve this equation. Now we are going to get absolute value of 10 minus 3 alpha, that will be equals to the square root of 25, that's 5, 5 times 3, that's 15, which gives us 10 minus 3 alpha equals to positive 15, or the other scenario, 10 minus 3 alpha equals to negative 15. So 3 alpha is going to be equals to 10 minus 15, that's negative 5, and then we have 3 alpha equals to 10 plus 15, that's 25. So we have two possible values. We're going to replace this in this particular equation, so we get 4x plus 3y minus 5. So here we have negative 3 alpha, but 3 alpha is negative 5. This will be one equation, and the other equation will be 4x plus 3y minus 3 alpha. So 3 alpha is 25, which gives us the two equation of the tangent line. So we have 4x plus 3y plus 5 equals to 0, and the other equation will be 4x plus 3y minus 25 equals to 0. So these are the two equations of the tangent line, and we're getting two equation because we have one more tangent. Let's call this as the tangent t2 prime, with the condition that it is also perpendicular to the straight line 3x minus 4y minus 1 equals to 0.